This is the solution to the fluids review problem number 1004. For the problem at the top of this page, which was problem 1000, what percentage of the sandstone is below the fluid line for the mercury, and how many centimeters of the sandstone disk is above the fluid line of the mercury? All right, so on the left-hand side are all the givens from the earlier problem, number 1000. And if I'm looking at it, I know that the percent of the volume that's under the line, that's under the fluid line, is a ratio of the two densities. So the density of the sandstone divided by the density of the mercury, and that's 20%. 20% of the sandstone is under the fluid line, so 80% is floating above the fluid line. All right, next. I know the volume is going to be the area, pi r squared, times the height. So pi r squared, again, the numbers came from problem 1000, times the height. So that's the volume of the original block, the whole block. And now I know that 80% of that volume is actually above the water line. So 80%, 0.8 times the whole volume, and that gives me the 0.509 meters cubed. So the 509 meters cubed, that's the volume that's above, so I've got to figure out the height. And that means that this number, 509, is equal to pi r squared times h. So if that's true, then when I look at h, if I isolate for h, it's 80% of the original volume times pi r squared. 80% of the original is just my same number that I had over here, 0.509, divided by pi r squared. And then when I isolate, well, when I solve it for h, I get 0.20 meters. So 20 centimeters are above the water line, or the fluid line in this case, not water line.